Here's a little video that I thought some of you guys out there might enjoy. This here is a recirculating pump, and this recirculating pump pumps the water to this bladder tank, which is hanging from the ceiling. And on the side you'll see a picture of the bladder tank, and it's in this position in the ceiling. So first of all, what we're going to do, this circulating pump, obviously you can look at it really close and you can see that the wires have been burned and damaged, and it also damaged the pump itself, so we're going to replace this pump. And what you see right now is we're cutting the copper pipe to the relief valve, and this relief valve is so that when the water pressure builds up too much, it will discharge the water out into the relief valve into a drain. And right here at the top you will see a picture of a pair of mini cutters. This is what I am using to cut the copper pipe with. It will cut up to 1.25 inches from down to 3/8, and it's perfect for getting into tight spots where you can't get a normal pipe cutter around. And by the way, you can pick these cutters up at plumberx.com. And this relief valve is of course it's a 1/2 inch outlet, but it has a 3/4 inch inlet. And what we're doing here now is we have a utility knife, and we're just cutting the insulation back off and away from the pipe so that we can get access and cut the pipe and remove the pump and prepare the pipe for the new pump. And it's my guess that this pump deteriorated pretty quickly because one of the facts, it doesn't have any dielectric unions, and you can see that the copper pipe is touching the metal pump, the cast iron pump, and also the galvanized T that you can see right there. And most plumbers would tell you that you don't want these two different materials of metal touching one another, because there's a thing that's called electrolysis that travels through the pipe and causes one pipe to deteriorate much faster than the other. And in this case, it's deteriorating the cast iron pump, which all of this more than most likely could have led back to the wire damage to the pump when the water started to leak out. So when we go back to install the new one, we're going to install some dielectric unions so that we don't have electrolysis traveling through the system and prolong the life of the pump itself. And what we're removing here is the sensor, the pressure sensor, which will it senses the check valve here, so that when the pressure is not adequate, it will make the needed adjustments to keep the bladder tank up to proper pressure and not over pressurize it or keep the pressure down too low. And it's electronically controlled. So when we're done with this project, we're going to have the electrician come in and have him rewire the component. Here's our new pump. The exact same pump. It has a 1.5 inch inlet right there in the middle, and coming out the top would be 1.25 inch outlet. And we're going to start prepping it up, putting the pieces, the galvanized nipples and the dielectric unions on outside here where we have a little more room to work. And then once we get it pretty much together, we're going to set it in place and start working on our connections. That's the galvanized nipple and the dielectric union. And what we have here in our hand is Teflon tape. This is the monster Teflon tape, real good Teflon tape, because we don't want any leaks. And of course we're going to put a new galvanized T on here. This is a 1.25 inch galvanized T. And at the top of that galvanized T, we're going to reduce it down to 3/4 inch for the new relief valve to go up on top. Yep, we're cutting this with a sawzall. Right now, this is the easiest way to cut it. The copper pipe cutter is not going to be able to turn around. There's no room for it. And you notice the wires on the sawzall. I do have it up in the air and away from the water. Good. Now we have a clean cut. And we're ready to remove the old pump. And if you're looking at the wires hanging from the side right there, it's been disconnected, so there's no power going through it right now. Nothing to worry about with the water, just in case you're concerned about. Now look like I will be able to cut this with the tubing cutter, and if not, again with the sawzall, because these two copper fittings are so close together, it makes it a little hard to actually get around the make the circle around the pipe to cut it. Well, maybe not. At least not right now. And what you see me cutting out here is the check valve. A check valve is a valve that allows water to go one way, but will not allow it to go back another. So there's only one direction that this water should be going, and to prevent it from backing up, that's what the check valve is there to do, controlled by the pressure device. And what we're doing now is just kind of sizing up the pump in the spot that the old one was in. Looking at the space and room we have to work with, and the necessary work that needs to be done before we can put it in place, like soldering the dielectric unions onto the copper pipes. Just using the pipe wrench to tighten down the one half of the dielectric union, which is the dielectric union that would be galvanized to galvanize and cast iron, which is okay. This is just one half of the galvanized union. And of course, we're just going to go ahead and tighten this galvanized T in position. And by the way, the pipe wrench that I'm using is a size 18. And what we're doing here is we're just taking the file and filing the excess copper that's hanging on the edge. And any piece of copper that might cause any restriction in the water, we're just cutting that out of there and filing it down so it be smooth, so the water can travel through and nothing can snag onto any rigid ends. And this extra piece of pipe I'm talking about is a lot of plumbers call it burr, and what I'm doing here is deburring the inside of the copper pipe, removing any of the excess copper that may be hanging over the edge. And most tubing cutters like this here, even the small ones, have a little device on the end where you can use it to deburr the pipes. And now we're going to deburr this one. And remember, when working on a copper pipe, be very careful. This pipe will cut you. I mean, those edges can be very sharp. So always work with caution when working with copper pipe. And this is the other dielectric union. This is the 1.25" dielectric union. And I'm going to tell you a little mistake we're making right here, right now, is that we may be putting the dielectric union on too soon. Obviously, I've seen the video first, so I know what's going to happen. But we're going to go ahead through this anyway so that you can see. And then we're going to straighten it back out. See, in this situation, the check valve should actually go first, but we didn't catch it until after we put this dielectric union on and say oops, and so we just swapped it around. Something else to learn on this video: no one's perfect. Here's a diagram, a small picture of a dielectric union and how they work. You can see the rubber piece in the middle and the piece on the edge, how it isolates the two metals from touching each other. That's how a dielectric union is designed. This is the galvanized bushing, the 1.5" by 3/4" inch galvanized bushing, where the again the relief valve is going to go on top of this. course, this is the relief valve. And I'm also putting a dielectric union on the relief valve too, since it is touching the galvanized fitting. And this is a 1/2 inch dielectric union. And you know, another good thing about these dielectric unions, or any union period, is that the next time someone comes through here and has to do any work, change out the motor or just repair it, they have easier access, because you can just disconnect it from the dielectric union and not have to go through procedures you're seeing me go through, cutting the pipe with the sawzall and tubing cutters. The next time someone just disconnect the unions and pull it right out of there. Well, you can see that we caught the mistake that we were about to make, but actually it wouldn't have went through anyway, because there was only one way that this could go. So what we're going to do now is, this time we're going to put the check valve on first, like we should have done the first time. The thing about the people ask about the brass and the copper being kind of the same material, but actually the brass would act as a neutralizer, so we don't worry about the brass touching the galvanized system. So that's why we don't have a dielectric union here on the check valve that we're putting in place. And again, this is an 18-inch pipe wrench, and we're going to use two 18-inch pipe wrenches to tighten this check valve in place. And you can see the picture here on the side. That is what the actual check valve looks like. And the two ports on top, one hole is for the electronic pressure switch, and the other port we're going to use to we're just going to block it off with a plug. which in some cases you might want to use that extra hole to put a pressure gauge. But in this case, we're just going to plug it off, just like the old one was. This is the plug where we're going to plug one of the holes off. Okay, now I've pulled the pump out so that I can have access to solder the dielectric unions onto the copper pipe. And I do apologize because I did run out of video on this, but I do have another video showing you how to solder dielectric unions that's posted here at the top, and you can check that video out. Now everything is in place. Now all we need is the electrician to come through, hook the wires up, and everyone's back in business. Thank you for watching plumberx.com.